Good morning, guys. Hope that all is well. So, yes, the other day what we covered for geometric figures and terminology was knowing what all the different things were. So just a quick review. If you see something like this that has two arrows and never stops in any direction, it's a line, right? If you have something that has a starting point and an end point with no arrows that just stops, that's a segment, right? And then if you have something that has a starting point and goes on forever in another direction, that's called array, right? And the only one that you can only label one way is array, because if this is F and that's M, the only way you can label that would be FM, right? And the only reason you can label it FM is because it starts at F and goes to M. If you were to actually label it MF, like this would be wrong, because this is telling you that it starts at M, which it doesn't. So always be careful. With array, you label it with the starting point and then where it goes to. Just always remember too, collinear means that it's points that are on the same straight segment, same straight line. And coplanar means that points that are all on the same plane. They all have to be inside the plane, not outside. So a quick review of what we did the other day. Today we're going to be working with segments a little bit more in depth. And we're also going to be working with a term called congruence. And if you guys haven't heard of it before, that's okay. We'll get to it then. But it's nothing that's complicated whatsoever. So again, dealing with segments, we know that a segment is a part of a line, right? That has a starting point and end point. If we were to call this, let's say, A right there, we were to call this C, you can label that segment two different ways, right? You can call it segment AC, or you can call it segment CA. But again, that's just two different ways to look at how you would label that segment. What we're going to go into today is we're actually going to try to figure out what measurements of segments are, right? So let's say I were to put another point right here and call this H, right? So now let's say that I were to tell you that AH is 2 inches, let's say, right? And let's say that I were to tell you that HC is, let's say, 4 inches, right? And I wanted to figure out the length of the entire thing. Let's say I wanted to figure out the length of AC as a whole, right? If I wanted to figure that out, let's look at what we know. We know that AH, and let me write it in a different color just so it's easier for you guys to see. Let's say that we know AH is 2 inches. So AH, we know that that's 2 inches right there, right? We know that HC right there is 4 inches, right? So we know that this part is 2. We know that this part there is 4. If we wanted to find AC, now AC is the whole thing. If we know that this part is 2, we know that that part is 4. Whenever we want to find the whole thing, you always have to add them because you have to put them together. So if we want to find the whole thing you always got to add. And it's like saying this, if you have 2 on one side, you have 4 on the other side, altogether you would do 2 plus 4, which is 6. So if that's 2 and that's 4, we know that this whole segment right there is going to end up being 6. That's all it is, guys, 6 inches. So the one thing about segments, whenever you're trying to find the whole part, you add. Now we're going to show you what happens if you're just trying to find a part of it, right? So here, let me get rid of everything actually. Let's say now that I was trying to find a part of it. Again, let me give you a segment right here, right? We got that segment. Let's call that M. Let's call that T. And then let me put this point right there on that segment too. Let's call that R. And in this case now, I'm going to say that MR is equal to, let's say, 5 centimeters, right? So we know that MR is 5 centimeters. Now I'm going to tell you that MT is equal to 11 centimeters, right? So let's look at what we know. We know that MR represents this part, right? MR. We know that MT represents the entire thing. The one thing I want to find out, I want to find out what RT is going to be, right? I want to know what RT is going to be. So again, let's look at what we know, right? In this case, we know that MR is 5, right? So MR is 5. We know right here that that's 5 centimeters, right? We know that MT, the whole thing, we know that this entire thing is 11 centimeters, right? We want to end up finding RT. We want to find this missing piece right there. We want to find this missing piece. So in order to find that missing piece again, remember, we're not trying to find a part. We're not trying to find the whole thing now. We know what the whole thing is. We have a part. We want to find the other part. So the one thing you always do, whenever you're trying to find a part, you always subtract. Whenever you're trying to find the whole thing, you want to add. Just like anything else that you would do. So if the whole thing is 11, right? We know that this piece is 5. Since we're trying to find a part, you subtract. Always subtract when you want to find a part. And 11 minus 5 is 6. So we know our answer is going to be 6 centimeters. Just because, again, we're trying to find a piece. And if you wanted to also see if it makes sense, check it. We know that if this is 5, right? And we know that that's 6. 6 plus 5 is going to give us 11. It's going to give us the whole thing. And again, don't ever go by the picture because a lot of times the images that you see doesn't necessarily make it look accurate. Just because it looks smaller doesn't mean that the numbers have to be smaller. And that's when you always usually see things that are saying not drawn to scale. It's for that exact reason. But always remember, guys, and there's a small note for that. If you're trying to find in the future, if you guys are trying to find the whole segment, right? You add. Always add. And if you're trying to find a part, you subtract. Always. And it's like saying if you have $50 in one pocket and you got $20 in the other pocket, how would you figure out how much you have in the other pocket? You would subtract. It's also like saying if you have $5 in one pocket, $10 in another pocket, all together you have 15, you would add. So whenever you want to find the whole thing, you add. Whenever you want to find a part, you subtract. So that's finding out segment lengths. Now, we're actually going to use some solving equations because it is also good to see this, and it's still the same idea, guys. Okay, and I'm going to try to make it as simple for you to see. So let's say we have this segment right there, right? Same idea. Got a segment right there. Let's call this right here, let's call that F, let's call that G, let's call that I, right? And I'm going to tell you that FG is going to end up being, let's say that this is 2x plus 5, right? And let's say that this here is going to be 3x plus 10, right? Now I'm going to tell you that I'm going to tell you that Fi is going to be equal to 35. And all I want you to do, I just want you to solve for x. All I want you to do is solve for x. Which again, seems complicated, but it's exactly everything you've already done before, guys. So you want to solve for x, right? We know that this part right there, we know that that's 2x plus 5, right? We know that this part is 3x plus 10. We know that the whole thing, this is the whole thing right there. We know that this whole thing is 35, right? We know that Fi, the whole thing is 35. So if we know what the whole thing is, all we would do is we know that this part's 2x plus 5. We know that this part's 3x plus 10. Since we have the whole thing, what you would do is say that this part plus this part equals the whole thing. That's all it is. It's saying that one part plus another part gives you the whole thing. So all we're doing is just adding those two. And once you set those two up, you would set it equal to 35. So again, all we're saying is that 2x plus 5 plus 3x plus 10 equals 35. We're saying that one part plus another part gives us the whole thing. 2x plus 5 plus 3x plus 10 equals 35, the whole thing. And now all we do is we literally just solve it, right? By combining like terms. We have 2x right there. We can combine it with 3x, right? So 2x plus 3x gives us 5x, right? So we're done with that, we're done with that. Now we can also combine the 5, because it has no variable, with the 10, because it has no variable. And always combine things on the same side, right? So we know that 5 plus 10 gives us 15, right? So we finished that and that. So all we did was we combined the x's together. 2x and 3x gave us 5x. We combined 5 and 10, which gave us 15, equals 35. And now it's just solving the rest of the equation, right? Anything with the variable, always save for last. So let's get rid of that 15, minus 15, and minus 15. Because whatever we are always doing to get rid of it, you have to do the opposite. You have to do the inverse. Opposite of addition is subtraction. And if I subtract 15 here, I gotta subtract 15 there. That cancels, right? So we're left with, I'll move it over here. We're left with 5x equals, and then we know that 35 minus 15 is 20. So again, all I did was subtracted 15 from both sides because it's the opposite of addition. And now to get x by itself, whenever you have a number next to x, it's multiplication. Opposite of multiplication is division. So if I divide this by 5, divide that by 5, x equals 20 divided by 5 gives us 4. X is 4. So the hardest thing about this idea, it's just knowing that whenever they give you two parts, and then they tell you how long the whole thing is, you want to add those two parts up, that part and that part, and set it equal to the whole thing, always. And again, I'll do another one just for you guys to actually see and feel comfortable with it. Let's say again that this segment right here, let's call this segment M. Let's call that MO, right? And then let's call this R right there. Let's say that this right here is going to be, let's say that that's 4x plus 2, right? And then let's call this here 6x plus 3, right? And now I'm going to tell you that MO is going to be equal to 45. And all I want you to do is the same thing we did before, guys. I want you to solve for x, right? Solve for x. Which again, it seems complicated, but let's look at exactly what we said we knew before, right? We know that this part here is 4x plus 2, right? So this here, MR, is 4x plus 2. We know that this part here, RO, is 6x plus 3. We know that MO, the whole thing, we know that this whole section right there is 45, right? So if we know this part and this part together give us 45, since they're together, you gotta add them, right? If we know that this part plus this part gives us 45, then we wanna add them, right? So that's all we do. It'd be 4x plus 2, right? Plus 6x plus 3 equals 45. And again, all I did was I said 4x plus 2, right there, plus 6x plus 3, right there, equals 45, equals the whole thing. And now again, same thing we did before. You want to combine like terms, right? So 4x has an x right there, 6x has an x right there. So we would combine the x's, right? 4x and 6x gives us 10x, right? Cross those out. We want to now combine everything that doesn't have the variable on this side, right? The 2 and the 3. 2 plus 3 is going to end up giving us 5, right? Equals 45. And again, anything that has to do with the variable, save for last. To get rid of the 5, we would do the opposite of addition. Opposite of addition, which is subtraction. So subtract from this side 2. The 5's cancel out. We're left with 10x. Let me put this here again. We're left with 10x equals, and then 45 minus 5 is 40. And now same thing. Opposite of multiplication when they're together is division. divide that by 10, and if I divide that by 10, I gotta divide this by 10, cross it out, x equals 4. And we got 4 again because 40 divided by 10 gives us 4. Always remember, whenever you're trying to solve this, if they give you the whole thing, you want to literally add those two segments up, because when you put those two together, it gives us the whole thing, guys. And again, you know how to solve equations. Let's get to the last thing we got to cover, and it's actually pretty simple as well. A lot easier for you most likely than this, and that's dealing with congruence. Now, what congruence means is when two things are congruent, it means it's the exact same thing. Congruent just means congruent. It literally just means equal. Equal measure. Exact same thing. So if one, let's say that two things are congruent, right? If one is 10, the other one is 10. If one's 100, the other one's 100. If something is congruent, it literally means that it's exactly the same. So when we're dealing with segments, the way that we show congruence, right? Let's say that we have this. And let's say I put this point here. If I were to look at this and this, some people would say that they're the same. But that's an assumption. You don't know that for sure. So you need to know for sure that those two are equal. You need to know that those two are congruent. In order for you to know that those two are congruent, we'll usually put something like this. And what that's called are tick marks. They're called tick marks. And what we use tick marks for is to literally show that two things are exactly the same. It doesn't always have to be one. It could be as many as you want, as long as it's always the same. So like if that has 2 and that has 2, they're exactly the same thing. If that has 3 and that has 3, they're congruent because it's the same amount. Now, if this has 4 and that has 3, they're not congruent. Because in order for it to be congruent, in order for it to be equal, if one has 4, the other one has to have the same amount. So since this has 4 and that has 3, it's not congruent. But now if I were to put an extra one there, if that has 4 and that has 4, that's congruent. It's all congruent means, guys. It just means exactly the same. And I'll show you again, because again, if they're congruent, let's say I have a segment right there. If it's congruent, if that's congruent to that right there, if this is 6, then that's going to be 6. And if that's 6 and that's 6, it means that the whole thing is going to end up being 12, which is the same exact idea we did before, which is if we know what the parts are, to find the whole thing, you add. Whenever you want to find the whole thing, you add. If you want to find a part, you subtract, which we're going to do practice again. But all I wanted you guys to see is if something is congruent, it means that they're both exactly the same. Congruent means exactly the same. So let's say now that I were to give you this, right? Let's say that we have this, right? We know that that's A. Let's call that C. Let's call that E. I'm going to show you right now that AC and CE, those two segments are congruent. I'm going to tell you that AC is equal to, let's say that it's 7 inches, right? And I want to find a measure of AE. Now, some people would say we don't have enough information, but you do. Think about it. AE is the whole thing, right? We want to find AE. So let's look at what we know. We know that AC is 7, right? And since they're congruent, if AC is 7, then CE is going to be 7, right? Because if that's congruent to that, they're both exactly the same, right? Now, since we want to find AE, we want to find this whole thing. If you're trying to find the whole thing, always remember, whenever you want to try to find the whole thing, you add, always. So if that's 7 and that's 7, we know that 7 plus 7 equals 14. So we know that our answer would be 14 inches. Because again, whenever you're trying to find the whole thing, AE, you add, right? And now the last one that I want to show you guys is, let's say I wanted to find a part, right? And this is where you got to be a little bit careful. And again, it's just thinking for a second. Let's say that I had this endpoint right there, that endpoint right there. We have this, right? This is D, that's F, that's H. And I'll tell you that DF is congruent to FH, right? If I were to tell you now that DH is equal to, let's say 30 centimeters, right? DH is 30, so this whole thing is 30, right? And all I want to do, I want to find DF. I want to figure out how long DF is going to be. So all I want to know is, how long is this going to be? The whole thing is 30. If I wanted to figure out now this part, realize something. You have two parts that are exactly the same, right? Since the whole thing is 30 and you have two parts, what we would do is just do 30 divided by 2. And the reason we're divided by 2 is because we have two that are the same, right? And again, it's the fact that they're the same. And since it's 2, we divide by 2. Because now 30 divided by 2 gives us 15, right? And that's all our answer is. And the way you check it is, let's say that we said that that's 15, right? So if that's 15, then that means that this would be 15 because they're congruent. And we know that 15 plus 15 is 30, right? 15 plus 15 is 30. And again, that's all because it's congruent. Since it's congruent, you have two parts that are equal. So when it comes to this, always realize something, guys. Congruent just means that they're exactly the same. If those segments are congruent, those two have to be congruent. And again, almost think of it as if you have $30 in your pockets and both of your pockets have the same amount of money, you would do 30 divided by 2 because you got two pockets. You did 30 divided by 2 because you had two parts that are the same. That's all it is, guys. Just always remember, whenever you're trying to find the whole thing, you add. Whenever you're trying to find a part, you subtract. When it comes to congruence, remember, congruent means the exact same thing, guys. They're both equal, and always make sure they have the same number of tick marks. If you have any questions, feel free to ask.